If you own a Threadripper system and you got an ASUS motherboard, you're going to be thanking G.Skill by the end of this video, even if you don't have G.Skill memory, because they're going to save the memory that you already have. What? What sort of madness is this? Oh, it's a little bit level 1 diagnostic. It's a little bit showcase for G.Skill's 512 gig kit of memory, but also a bug. There exists a bug in the platform that might kill your DDR5 memory. If you have an ASUS TRX50 or WRX90 motherboard, you need a BIOS update. Let's take a look at what I found. This one's going to be a little weird. It's one part autopsy, one part level 1 diagnostic, one part product showcase. And if you have a Threadripper system and an ASUS motherboard, you're definitely going to want to watch this because you're going to need to update your BIOS. Yeah, it's pretty interesting. A while ago, it's July, it's been a few months, I pointed out, I was like, hey, DDR5 silent throttling can be a problem. And I did a bunch of testing and showed throttling on our test bench with Gigabyte and ASRock motherboards. Well, G.Skill reached out and they said, hey, we don't think that our DDR5 ECC kit for Threadrippers, 512 gigabytes, an awesome luxuriant kit that we will take a look at in a second because I also was putting together the review for this video, but I ran into some anomalies. We don't think we need heat spreaders. It doesn't throttle. And so I was intrigued. Color me curious. And so I said, okay, send me your kit. Send me 512 gigabytes of memory. Yeah, I know how much this has become. We've been doing this project on Patreon of Floatplane, so I have a video from about a month ago where we're taking this kit for a test and we're doing some testing in OCCT. So this is kind of a follow up to that video, but that video is going to remain on Patreon of Floatplane. This is the result. There was a piece of information that I didn't have perfectly, but yeah, G.Skill. Bottom line, G.Skill was basically right, except for in the most extreme artificial scenarios. Their 512 gig kit of ECC memory at DDR5 6000 was great. It was fantastic. Or 6400, I'm sorry. DDR5 6400. Their kit is fantastic. Now, that is not JEDEC 6400. That is just 6400. I also have some JEDEC 96 gig 6400 DIMMs. Boy, I wish I'd bought more of that when I bought it earlier this year. Could sell it and buy a yacht. But yeah, no, it's not about that. But there is a 3D printable fan bracket as well that you could sort of. Let me start at the beginning. Let me grab the Threadripper machine. This is not an atypical Threadripper workstation. What's atypical is that the value of this workstation has appreciated as dramatically as it has. This is a 9000 series Threadripper, a 64 core in a Pro motherboard. Now, our motherboard here is an ASRock motherboard. It's the WRX90. It has 5 little fans on the VRM, which I think is more of a turnoff to people than ASRock realizes. Some people. It doesn't bother me because the fans don't really run all that much unless you're overclocking, and not really, it's not like even significant overclocking. I'm not really overclocking with this platform. But installed in here, we have our 512 gig G.Skill memory kit, which is flawless. This is very low latency. It is relatively power sippy, and it runs really well in every normal scenario I was able to come up with. Since July, I tweaked and released a memory latency checker, Intel memory latency checker utility, the one that I was using in the video in July, a script to help you use MLC to check your memory and see if it's throttling. Now, our platform here throttles memory correctly when it overheats, and it is possible to induce overheating on this platform, but by and large, you're not going to run into it in any normal scenarios. If you're on TRX50, that's 4 memory channels. There is a version of this available from G.Skill that is 4 memory channels as opposed to 8 256 gigabytes of memory, and those are even easier to cool. The other thing that we learned with this is that between 32 and 64 cores changes the thermal characteristics and thermal performance of the memory. It makes sense if you're really read into how this platform works. This is one of the boats that I think AMD missed with the 9000 series Threadripper updates, and that is you need more cores to keep the memory more busy which in turn produces more heat. It's a little disappointing that Threadripper Pro 32-core can't really take full advantage of the memory bandwidth of all 8 channels. You see, because there is an EPYC CPU that can do that. One of the EPYC F series CPUs has what's called a dual GMI link. That means each chiplet has 2 connections. I think AMD missed not having a Threadripper Pro CPU in the lineup this time around that would give you that full memory bandwidth, especially when we're talking about large language models and building a machine where you're doing hybrid inferencing on both CPU and GPU, being able to run, you know, a model on your GPU, but then you don't have enough VRAM. You never have enough VRAM, but it could spill over into 512 gigabytes or a terabyte on your CPU platform. That is a really nice feature to have. Fortunately, AMD did enable CXL, I think unofficially, on Threadripper Pro. So if you have the need for crazy amounts of memory, this is 512 gigabytes on a card with 428 gig DIMMs. This is a smart modular CXL device. We did another video on this. These need a lot of cooling, but if you give them a lot of cooling, you can add another 512 gigabytes of memory, DDR5, to the system, and it'll run through the PCIe bus. So it's bottlenecked, quote unquote, at 64 gigabytes per second. So you're only going to add 64 gigabytes per second to your bottom line, you know, memory bandwidth. But if you just need capacity for a large language model, this can get you over the finish line. Like, don't leave CXL out entirely. But as far as I can tell, these Threadripper Pro platforms only support a single CXL device. So this is the one you want. Smart Modular has another one of these that has 8 DIMM channels, but it actually has 2 CXL controllers on one PCIe card that's designed to run in an X8 configuration. I wouldn't recommend that for Threadripper Pro because Threadripper Pro seems to only support the one CXL device, depending on your motherboard layout and some other factors. So if you have a 24 or 32 core Threadripper Pro, especially on the 8 memory channel platform, chances are you're never going to be able to push the memory to a point where it throttles unless your cooling is subpar or worse. Now, this is a Fractal Meshify 3. This is a great case for cooling. Torrent remains the uncontested champion. So if you are building something that is relatively high heat production, I encourage you to take a look at the Fractal Torrent with its giant 180 millimeter front fans. But, you know, our Meshify 3 XL here is not bad and is a relatively inexpensive case for what it is. Some of the last generation Fractal cases, like the Define 7 XL, they don't really have a proper successor because everything is wildly expensive these days. But still, looking to see that, looking to have something with that. Our RTX Pro 6000 also dumps 600 watts of heat directly onto the memory, and so cooling can be a little bit of an issue. Enter this 3D printed bracket thingy. Gigabuster and I worked on this on the forum, and he came up with this design based on some loose testing that we did. And believe it or not, there's more engineering that went into this than would appear. We're using the Bernoulli effect to dump air over the memory, and even though these little Arctic 15K RPM fans are not moving at 15,000 RPM because they would be absurdly loud, they move a fair bit of air, and they do a great job cooling our DIMMs. You do have to run these at a relatively high RPM in the torture test scenario to keep an eye on your memory cooling. Now, another thing in the setup is OCCT. OCCT has a great memory test, and I have since been in contact with the folks that wrote OCCT, and we're discussing some things behind the scenes, but OCCT is a great artificial benchmark, and I'm not aware of any actual real applications. I'm aware that they're out there, but I'm not aware of what specifically they are and how they work. But there are a couple of people that have messaged me privately on the forum to talk about this issue and errors that they ran into with specific applications, and this has solved their issue. Now, this is designed specifically to mount to the Silverstone 360 AIO. There's an alternative design that mounts to another different Silverstone cooler. If you don't have a Silverstone cooler, then you don't have anywhere to mount this on the socket exactly, but these two 40 millimeter fans from Arctic makes fantastic long life, like server grade fans. That's what these are. We're just running them at a relatively low RPM from our fan headers. It's definitely not amazing in the torture test with OCCT. And this is even a little harder on it than the MLC, the memory latency checker utility that Intel has, which is really quite good. This doesn't show the loss in memory bandwidth as concretely as MLC does. It's great that MLC is like, oh, everything's 200 gigabytes a second. Oh, everything's 100 gigabytes per second when your memory's overheating. but you do see the dropouts in reporting. And sometimes you'll actually see WHEA errors reported in OCCT here. Now, OCCT reports DIMM temperatures and is able to access the management chip and that sort of thing. OCCT has a better view from ASUS motherboards than it does from ASRock motherboards because ASRock puts their management chip at a different address. And I don't think OCCT or Hardware Info 64 have bothered to, deal with the fact that the monitoring chip is at a different place. And the reason I say that is because DDR5 DIMMs have 3 temperature sensors. There's one in the voltage regulation area that's sort of at the middle top of the DIMM, and that can run really hot in a lot of modern DIMMs, like 115 degrees C. The other parts of the DIMM, or where the memory is, and there's one sensor on each side, typically. And depending on the specifications of the memory chips themselves, G.Skill doesn't have a lot of control over this part of it. You may start to see throttling creep in at 75 or 95 degrees C. We talk about that a little bit in the video from July. There's more of a deeper dive there, but just know that there's 3 temperature sensors here, and things can start to get sus past 75 degrees C. Now, what is supposed to happen, and what does happen on our ASRock and Gigabyte motherboards, is once the memory chips are beyond a certain temperature threshold, the memory speed goes to half. And that is easy to demonstrate with the MLC script that I wrote. If you're using some of the specialty utilities on Linux, it works great. MLC also works on Windows, so I have a PowerShell. I ported from Bash to PowerShell. There's a PowerShell version of the script for MLC, but also OCCT. I think OCCT is really the easy button here for checking your stuff. Now, these boards also have out-of-band management. The out-of-band management doesn't read all 3 temperature sensors. I don't know which one it reads. It'll read one of them. And it's the same A-speed chip, whether you've got the ASRock board or the ASUS board, and OCCT and Hardware Info 64 can read those DIMM temperatures. And so you'll see those in Hardware Info 64 when you're looking for them. The problem is that ASUS has done something. ASUS! If you have a TRX50 or WRX90 from ASUS, the latest BIOS as of the end of November 2025 does not reliably turn the throttling on when your DDR5 memory is starting to crater. And so that's part of this video. It's like, you got to protect your memory. You got to cover your memory because memory is super expensive. You can run your memory so hot that it will fail catastrophically. The problem is that if your memory is running so hot, you're starting to get ECC corrected errors. You're already past the point of like where it's supposed to be in the specs. Like a little bit of error correcting, like an occasional bit or two is fine. But like 10, 15, 100, 1,000 errors, in an overnight test, that is atypical. That is not normal. You will need to cool your memory, and that is what this is for. And so we all have G.Skill to thank for sending me a kit of memory so that I could do more exhaustive testing and also be challenged on, well, we don't think our memory, needs heat spreaders. G.Skill was correct on that. Their memory does not need heat spreaders. It is fantastic. It is well designed. So even doing a 4-hour torture test where we just run MLC over and over and over again, we don't get any thermal throttling the way that I showed in my video about thermal throttling and performance a long time ago. So yes, G.Skill's claims validated, at least for this specific hardware configuration. The DIMMs don't throttle. 512 gigabytes of memory at DDR5, working fine. The temperatures do get a little toasty, but no throttling. And in fact, having more gaps for the memory, more gaps in between the memory with a setup like this is preferable and does work better than memory with heat spreaders, because with the heat spreaders, the DIMMs are too close together and it is harder to get cooling down in there. You're gonna, if the universe of possible memory options include that, then you will have to design a different alternative interface for this. Enter Falcon Northwest. This is something I was worried about, so I reached out to Falcon Northwest. We chatted. We had a collaboration. Falcon Northwest took our design and they made it out of aluminum. And for their purposes, they wanted something quieter and that was even more effective. So they went with an even more elaborate design. And this is our Falcon Northwest system. Now you have to understand that I have driven Kelt at Falcon Northwest absolutely insane with a million questions Because it's like, no, it's fine. I'm like, no, check this. And it's like, oh, yes, you're right, it's not fine. So we've been working together. It's been doing fantastic work. And they came up with this. It's a dual fan design that also mounts to the Silverstone cooler. And it works fantastically well. See what I did there? Pun intended. So this configuration in the Talon, this is like the smallest 96 core, again, RTX Pro 6000. I added that. That was a me upgrade. It's a little messy in here because I've been rooting around doing bad things. They'll send it to you in a much better configuration than this. But let me tell you, I have had a blast running OCCT on this thing and trying to get it to throttle. Now, currently in this system, I have the 96 gig SK Hynix server memory. And this memory is extremely unforgiving of those temperatures. It expects to be in an insanely high airflow server all of the time. And the fan configuration that Kelt has provided with this definitely will give you that. So, well done. And so that's resolved now. Falcon has added even more aggressive cooling in their configurations while we wait on ASUS to fix their platform issues. Now, it is possible to get the ASUS platform to throttle memory in some configurations. 7000 series Threadripper CPUs seem to be fine. 9000 series Threadripper CPUs, whether on TRX 50 or WRX 90, don't seem to throttle reliably. Sometimes, after you load optimized defaults in the BIOS and don't make a change, throttling will work for a couple of reboots, or one or two. One, maybe I saw it like once on a second reboot. But after the machine has been on for a while, or you turn it off and back on, it stops throttling. And so this is being investigated. There's a BIOS update. But all of this is a lot of words to say, if there's a chance that your memory will throttle, you really should be putting extra cooling on the memory anyway. There's another data point that I hesitate to get into a little bit, but the other data point is on the Level 1 forums over the last year, as people have been working on their Linux machines and doing stuff with desktop memory. Now, this is registered ECC memory. We have a lot of telemetry here, temperature sensors, a lot of good stuff. Desktop memory, I'm talking AM5 and LGA 1700 and, Core Ultra systems, have had some instability. And in a surprisingly large number of cases, working with those users on the forum and having them add extra cooling to their DDR5 desktop memory, just 2 DIMMs, resolves some of their stability issues. We see instability in DDR5 memory in some kits from some vendors as low as like 55, 60 degrees C. 75 degrees C should be safe. 95 degrees C is definitely the danger zone. A lot of the time, this will be published in the memory kit documentation or in the documentation for the specific chips used. Now, G.Skill, for their part here, 95 degrees C. And everything is engineered really well with these DIMMs. In fact, they even add extra safety fuses in case the DIMMs start to fail catastrophically. There is an extra DIMM, a fuse that is built in on the G.Skill kit of memory, which I think is a recent change in the memory specification. Like if you look really close and see what's going on. So DDR5 ECC memory, registered ECC, you have to remember, was originally designed for server platforms with absurd levels of airflow. And some desktop cases will give you that without also piercing your eardrum. Some will not. Some system integrators like Falcon Northwest will pour a mountain of effort into resolving these kinds of problems and also building a desktop as reasonable as they possibly can, while also making sure that it doesn't split your ears or do anything bad like that. Some of you may recall our Falcon rack system that I got last year, which is based on Zen 4. We upgraded to server class memory, and we immediately 3D printed shrouds to deal with the server class memory and the cooling that goes with that. Well, now the problem has compounded with Zen 5, in my opinion, and we have that plus the bug on the ASUS platform means that there is real danger for your memory to overheat catastrophically depending on the workload that you're running, or at the very least have WHEA errors. So you can print a fan bracket, you can pick up some Arctic coolers. These running at about 4,000 to 6,000 RPM are pretty quiet. They're not inaudible, but it's pretty close. It depends on your case. Just the sheer mass of the Falcon Northwest case with these at like 4,500, 5,000 RPM does not bother me in the least. Can only barely hear it. Whereas in our Fractal Mesh Phi 3 XL, it's a little more audible. And now you know the rest of the story. So Massive props to G.Skill, because I probably wouldn't have discovered the ASUS BIOS bug without having so many kits of DDR5 ECC in order to discover this, but also for them putting in the work and engineering that their kit will tank these bad situations a lot better than reference kits or engineering kits or kits that are designed for like server use. Like that's most of the kind of memory that I'm buying is memory that is originally designed for server use. Falcon, for their part, they are also very, very picky with the memory configurations that they use, and now you know why. So yeah, big thank you to G.Skill. Check out this memory if you're building one of these for work and you have to buy it because no matter what you have to get the machine. It would behoove you to check out G.Skill's 512 gig kit for their platform. I've been really impressed with it. I've been using it since November, and we've done a lot of bad things to it, and it has survived all of the bad things that I did to it. You have to understand that I didn't know that the ASUS motherboard wouldn't throttle. And so these DIMMs have seen temperatures in excess of 115 degrees C, and they're still here to live to tell the tale. Whereas some server memory that experienced something similar, I'm down a DIMM or two. Like, it's not a great situation. But G.Skill did an excellent job here, and we'll be waiting with bated breath for that ASUS BIOS update, or I'll pin a comment below, or join us in Level 1 forums, because this is the kind of crazy stuff we're doing. Madness. I'm Whittles Level 1. If you have any questions or I miss anything, hit me up in the forum, because that's what we do. All right, I'm signing out, and I'll see you there. Woo, fixing things. Yeah, no, Level 1 diagnostic computer janitor. Okay.